This lesson corresponds with Roman numeral 4b in the Unit 8 Honors Notes packet. This is on molecular formulas. Yesterday we did empirical formulas. So what is the difference between them? An empirical formula, as you learned yesterday, shows the lowest whole number ratio of moles in a compound. But a molecular formula can be a multiple of it. So, for example, you could have the empirical formula CH2O, and this represents the lowest whole number ratio of 1 to 1. However, the molecular formula could be a multiple of this, such as glucose, C6H12 and O6. Now notice that you have the same ratio, 1 to 2 to 1, but yet you've got higher numbers. This is known as a molecular formula. There are 3 steps used to convert from an empirical to a molecular formula. First, you must find the GFM of the empirical formula. Once you have that, you may divide the GFM of the molecular formula divided by the GFM of the empirical formula. And finally, multiply each subscript by the number that you get from step 2. Let's try some examples. In this first example, the empirical formula is CH4N. First, I'm going to find the GFM for that empirical formula. Carbon's mass is 12. There are 4 hydrogens, each with a mass of 1, so I'm going to add 4. And nitrogen is 14. When I add those up, the GFM of the empirical formula is 30 grams. Step 2, I will divide the GFM of the molecular formula given right here in the table, 60, divided by the GFM of the empirical, which I just calculated is 30. And if I divide those, that's 2. What that means is that my molecular formula is going to be twice the size of my empirical formula. So my new formula is going to be C4H8N2. I took the 1, even though I couldn't see it, I knew if there's nothing there, it's a 1, times 2 is 2. The 4 from the hydrogen times 2 is 8. And again, although we don't see anything, we know there's 1 nitrogen times 2 is 2. Pause now and try the other 2 examples on your own before checking them. So in the second example, sodium oxide has a GFM of 23 plus 16. That gives us 39. We take the molecular formula's GFM, 78, divided by the 39. Again, it's going to be twice as large as the empirical formula. So we do each subscript times 2, Na2O2. In the last example, we have 2 carbons, so 12 times 2 plus 1 hydrogen, 1, and chlorine is 35.5. When we add these up, it's 60.5 grams. If we divide 181.5 divided by 60.5, that means that the molecular formula this time is going to be 3 times as large as the empirical. So I multiply carbons 2 times the 3, gives me C6. Hydrogen and chlorine both started as 1, so I multiply by 3, H3, and Cl3.